city man's last resort. Because everything on the outside would kill us. We're like crabs in a barrel, fighting to get to the top. Pulled down by everyone else.
Want to unlock the power to create cinematic visuals at the speed of your imagination? Unreal Engine is really changing the game for filmmaking.
With real-time and virtual production tools.
Exactly. And if you're keen to get up to speed, without digging through tons of documentation, you've landed in the right spot.
Yeah, definitely. This deep dive is all about giving you that shortcut. We've basically boiled down the essential workflows for making really stunning cinematic stuff in Unreal Engine.
And you pulled this from expert YouTube tutorials and bits from Unreal Engine for Filmmakers.
That's right. A whole stack of them, plus the book. Our mission is just to get you the core knowledge you need nice and quick.
So we're covering everything from the basics, like making movie-like sequences, getting lighting right,
all the way to more advanced stuff, like virtual art department workflows, real-time asset creation.
Plus the foundational concepts from the book itself.
Yeah, exactly. Think of this as your fast track to understanding cinematic creation in Unreal.
Okay, sounds good. Let's jump in. Where does the magic really start?
Well, a really natural place to begin, bringing stories to life visually, is figuring out how to create moving images inside Unreal.
Okay.
And that leads us straight to Sequencer. That's the engine's nonlinear timeline editor.
Sequencer. Okay, sounds a bit technical. But it's basically Unreal's version of, Adobe Premiere or Final Cut.
Pretty much, yeah. Think of it as your main hub for animating almost anything in your scene over a timeline.
Like cameras, character.
Exactly. Cameras, characters, which are usually skeletal meshes. 3D models with bones for movement, lights, visual effects. Sequencer handles it all using keyframes.
Right, keyframes. We've heard that term in animation. So what's the very first step to using Sequencer?
You start by creating what's called a level sequence. You'll find the option up in the top left of the Unreal editor.
Okay.
And just for good organization, especially when you start having lots of shots, it's smart to make a shots folder in your content browser.
Makes sense. Keep it tidy.
Yeah. Then just save your new sequence with a clear name, like shot 001 or something similar.
Yeah. Got it. Sequence file created. How do we get things moving then? Add some life to the scene.
Right. That's where animation tracks come in. You can grab an asset from your scene, maybe that Fox character from one of the tutorials, and add it to an animation track in Sequencer. Once it's on the timeline, you can start setting keyframes for its properties. Things like its location, its rotation.
So setting snapshots in time where it is, how it's turned at that exact moment?
Precisely. And a quick tip for workflow. Dock the Sequencer window at the bottom of the Unreal editor.
Okay. Why is that?
It just gives you way more space to work, especially with complex animations. It feels more like a dedicated video editor then.
Good tip. More screen space is always good. Okay, Fox is on the track, Sequencer is docked. How do we actually add the keyframes?
It's pretty simple, actually. You move the playhead, that's the vertical line, showing where you are on the timeline to the frame you want. Then, next to the property you want to animate, like transform for location and rotation, there's a little plus sign. Click that, and it adds a keyframe right there, capturing the asset's current state.
Easy enough. And if we need to tweak the Fox's position at one of those keyframes?
You just select the keyframe, and then you can either drag the object around in the main window, the viewport.
Visually, okay.
Or you can type in exact numbers for the XYZ coordinates right there in the Sequencer panel.
Precise control.
Yeah. And one really important thing that came up on a tutorial was adjusting the Z-axis, the height.
Yeah.
Especially if your character's moving on uneven ground.
Right, so they don't sink in or float above it.
Exactly. Keep those paws grounded.
Unless you want a ghost fox.
Yeah.
So what about more complex stuff, like blending animations, say going from a run to sitting down?
Sequencer handles that really nicely. You can add multiple animation tracks for the same character.
Okay.
So you could have a run animation on one track and maybe an idle or sit animation on another. If you overlap those tracks slightly on the timeline, Unreal automatically blends between them. Creates a really smooth transition. We saw that with the Fox, blending the run into the anim Fox go tourist animation.
That sounds super useful for believable movement. What about the camera? How do we make it move?
Right, camera animation is crucial for storytelling. You add a SYNC-camera actor to your scene that gives you realistic camera controls.
Okay.
Then you add its transform properties to a track in Sequencer. So you can keyframe its position, its rotation, panning, tilting, dollying in or out.
Just like animating the character.
Exactly. And a really key thing to remember, if you animate the camera's location, you also need to animate its focus distance.
To keep the subject sharp.
Precisely.
Yeah.
You don't want your focus pulling unintentionally just because the camera moved.
Makes sense. Those little details matter. Okay, scene's animated, camera's moving, focus is right. How do we get this out as an actual video file?
Sequencer has a render button. Looks like a clapperboard icon. Click that and it opens the movie render settings. There, you choose your output format. An image sequence is often best for quality and flexibility later.
Like individual frames.
Yeah, PNGs or EXRs. Or you could render directly to a video file like AVI, though image sequences are usually preferred for serious work.
Okay.
Then you set your resolution, like 1920 by 1080. Your frame rate, maybe 30 frames per second, is common for cinematic stuff, and choose where to save the files.
And then just hit render.
Pretty much. Click Capture Movie, and Unreal starts crunching through the frames. You often see a little preview as it goes.
Fantastic. So Sequencer really is the heart of putting the movie into Unreal Engine. Okay, let's switch gears, making things look good. Let's talk cinematic lighting.
Absolutely. Lighting is just huge for mood and atmosphere.
Yeah.
Unreal gives you a lot of tools. A great starting point is the Environment Light Mixer.
Environment Light Mixer.
Yeah.
Sounds comprehensive. What's in there?
It's basically a central panel for your main environmental lights. Skylights for general ambiance, atmospheric lights, volumetric clouds. It brings them all together. But before you even touch those, there's a super critical first step, dealing with exposure.
Exposure, like on a camera.
Exactly like a camera.
Yeah.
By default, Unreal tries to auto-adjust the brightness. For games, that can be fine, but for cinematics, you want consistent exposure across your shots.
Right, you don't want the brightness jumping around.
No. So you add a post-process volume to your level. Make sure you check the box for infinite extent unbound, so it affects everything.
Got it. Affects the whole scene.
Yep. Then, in its settings, find exposure, turn on metering mode, and exposure compensation. And then, this is key, set both the minimum and maximum exposure values to zero. Zero. That locks the exposure. Manual control.
Okay, locked exposure. What's next for foundational setup?
Well, Unreal also does something called tone mapping by default, which affects the final colors and contrast. For maximum control, especially if you plan to color grade later in another program, you generally want to turn this off initially.
Where do we find that?
Still in the post-process volume settings, under color grading, then miscellaneous. Turn off blue correction, expand gamut, and set the tone curve amount to 0.
Okay, disable tone mapping for now.
Yeah, you could always turn it back on later to preview once your base lighting is set up.
So exposure locked, tone mapping off. Now we can actually add lights.
Now we play with lights. A good way to start is often to turn off all the lights you might already have, then turn them back on one by one.
To see what each one does.
Exactly. See its contribution. The main one for simulating the sun is the directional light.
Right, the sun.
When you add one, make sure its mobility is set to movable for dynamic lighting, and definitely enable atmosphere sunlight. That makes it interact realistically with fog and sky.
Okay, movable directional light, atmosphere sunlight enabled. What about making the scene feel less empty? Adding atmosphere.
That's where exponential height fog comes in. It simulates fog or haze that gets denser higher up. You can tweak its density, turn on volumetric fog so light rays interact with it, adjust the start distance for how far away it begins.
Creates that sense of depth.
Yeah. And then there are volumetric clouds. Unreal has a whole system for generating dynamic, realistic clouds that also interact with your lighting.
So we're layering up the atmosphere. How do we make that sunlight, the directional light, feel more real, more visually interesting?
Good question. One trick is to increase the source angle on the directional light.
Source angle.
Yeah. It basically makes the light source appear larger, like the sun isn't just a tiny point. A larger source angle gives you softer shadows.
Ah, softer shadow edges. Nice.
You can also adjust the intensity scale to make it brighter or dimmer. And remember, that volumetric fog interacts with all your lights.
Right.
So for fine control over how much a specific light cuts through the fog, it's usually better to adjust the volumetric scattering intensity on the light itself, rather than tweaking the fog globally.
Got it. Control the light's interaction with the fog, not just the fog itself. What about adding more specific dramatic lights?
For that, spotlights are your friend. They cast a focus beam, great for highlighting things or creating cool shadow patterns.
Like stage lighting.
Kinda, yeah. And the light mixer we mentioned earlier is really helpful for managing all these different lights as your scene gets more complex.
Okay.
And another key tip for spotlights or other added lights, Select them, go to their details, and set their volumetric scattering intensity to 0.
Why 0 for those?
It stops them from creating unwanted extra fog. You want your main volumetric fog to be the intentional atmospheric effect.
Right, keep it clean.
Exactly.
Yeah.
And then once you've tweaked all your lights, you'd probably turn tone mapping back on in the post-process volume to see the final intended look.
Makes sense. Cycle back to check the final image. You also mentioned HDRI lighting briefly.
Yes. High dynamic range images, HDRIs. This is a different approach where you use a special panoramic photo taken in the real world to light your whole scene.
A photo provides the light.
Yeah, these photos capture a huge range of brightness information. It can give incredibly realistic, nuanced lighting that matches a real location.
Cool. How do you use that in Unreal?
You need to enable the HDRI plugins first in the plugins menu. Then you can import an HDRI image and use it with a skylight. It's a very powerful technique for photorealism.
Okay, sequencer for motion, comprehensive lighting tools. We're building a solid picture. But before we light anything, we need the actual stuff in the scene, right? The environment itself.
Absolutely. Let's talk about building the visual vocabulary in that really crucial early stage, blocking out environments.
Visual vocabulary blockout. Sounds important.
It really is. This is where you make the big creative decisions early on before you get lost in details. Doing this well saves massive time and money later by avoiding rework or reshoots.
Like sketching the blueprint before you build the house.
Exactly like that. And this is where the virtual art department, the VAD, is becoming so central.
VAD. Tell me more about that.
The VAD handles a lot of the final image creation now, blurring the lines between traditional pre-production and VFX. Honestly, the line between VAD and VFX is getting fuzzier all the time.
Oh, so.
Well, think about those giant LED walls you see on film sets now. VAD creates those incredibly detailed digital environments that are displayed on the screens, and the actors perform right in front of them. That's final imagery being handled way upstream.
Wow, that's incredible. Acting against the final digital set in real time. So how do we start building this visual vocabulary that informs these environments?
It always starts with reference, gathering real-world images, architecture, materials, textures, props, anything that inspires the look and feel you want.
Just horde images.
Well, you gather, but then you curate, study them, build that mental library. But don't get overwhelmed. Be selective. Tools like Pinterest are great for organizing boards.
Okay.
And another fantastic tool specifically for this is PureRef.
PureRef. Haven't heard of that one.
Oh, it's brilliant for reference. You can just drag and drop images, paste them from your clipboard, arrange them however you want, zoom in, crop.
Sounds handy.
And the best part is you can set your PureRef board to float on top of other applications like Unreal Engine. So your references are always visible while you work.
Ah, that's really useful.
Yeah, VAD artists use it a lot to create call-out sheets too, like specific images highlighting roof details or textures they want to clearly communicate the art direction to the team.
Super efficient for visual communication. Any other good reference resources?
Yeah, ShotDeck was mentioned as a really valuable one. It's a database of high-res film stills.
Stills from actual movies.
Exactly. And it has great metadata camera, lens, sometimes even film stock info. It's not free, but apparently very useful for filmmakers and artists. You can make decks, which are like Pinterest boards.
Okay, got the reference gathering sorted. How do we translate that into the first 3D version of our scene?
That's where white boxing comes in, or gray boxing. You use really basic shapes like cubes and cylinders in a 3D program like Maya, just to quickly block out the scene's layout and scale.
Just simple shapes?
Yep. It seems basic, but it's critical for nailing down the feel, the mood, the focal points, the composition early on.
Before getting bogged down in detail.
Exactly. And a technical tip. Before you start whiteboxing in Maya, set your working units to centimeters. That matches Unreal's default units.
Good to know. For consistency.
Yeah. And maybe adjust Maya's grid to be similar to Unreal's grid options too. It just makes the transition smoother later when you import that block out into Unreal.
Right. Start simple, define the space, get the foundations right. Okay, now let's make those simple shapes look good. Look, development texturing and materials.
Precisely. Once the block out feels right, you start adding the visual richness with textures and materials. And a key concept here is texel density.
Texel density. Okay, break that down for me.
It's basically about how much texture detail you have per unit of surface area on your 3D model.
Like pixels, but for textures on a 3D object.
Kind of, yeah. Texel density helps you decide if an asset needs its own unique texture map that fits into that standard 0 to 1 UV space.
The UV map.
Yeah, that 2D layout of the 3D surface. Or if the asset is really large or needs repeating detail, maybe it's better to use tileable textures within Unreal.
Textures that repeat seamlessly.
Exactly. The example uses cubes of different sizes. Even a huge 8K texture map might not have enough detail for a massive object if its UVs are spread too thin across that 0-1 space. So for large walls or floors, tileable textures are often the way to go.
Makes sense. Use the right tool for the job. So where do we actually create these textures?
Quixel Mixer was highlighted as a really user-friendly option, especially for creating textures with layers and variations, which you can then use for vertex painting in Unreal.
Vertex painting.
Yeah, that lets you blend different materials directly on the model surface inside Unreal. Mixer has a nice interface, a big library of surfaces like brick or concrete you can start with.
Easy to get started then.
Yeah, you can easily turn displacement previews on and off, see how it tiles. It's quite intuitive.
And you can layer materials in Mixer, like plaster over brick.
Absolutely. Layer them up, adjust how they blend, control the height difference. You can get really nice variations. You can add decals too for small, unique details.
Decals like graffiti or posters.
Stuff like that, yeah. And Mixer has a cool masking system where you can reveal layers underneath selectively, and it handles the tiling automatically within the mask.
Sounds very flexible. Okay, we've made our awesome texture in Mixer. How do we get it into Unreal?
First, you export the texture maps from Mixer. That's usually your albedo color, roughness, normal map, maybe displacement AO.
The standard maps?
Right. You choose a preset like Metalness Workflow, pick your size, like 4K, and save it now. Then you import that material you just made into Quixel Bridge.
Bridge? What's that?
Quixel Bridge is like the hub for all Quixel assets,
Yeah.
including stuff you make in Mixer. From Bridge, you can then directly send that material straight into your open Unreal project.
Ah, okay. Bridge connects Mixer to Unreal. So the texture is Unreal now. How do we apply it to our 3D model, like that metal lamp example?
The best practice in Unreal is to use master materials.
Master materials.
Yeah, think of it as a template. You create a base material, say MBasic, and you set up parameters in it like placeholders for the base color texture, the normal map, the roughness value, etc.
Reusable template?
Exactly. Then, for your specific asset like the metal lamp top, you don't make a whole new material. You right-click your master material, MBasic, and choose Create Material Instance.
Okay.
You name that instance something specific like My Metal Lamp Top. Then you assign that instance to the lamp model in the editor.
And then?
Then you open the material instance, and you'll see all the parameters you set up in the masters. You just plug your specific lamp textures, the albedo, normal, etc. you imported into the right slots in the instance.
Ah, I see. So the master defines the structure. The instance holds the specific textures and values for that object. Much cleaner.
Way cleaner and more efficient. You change the master, and it can update all the instances if you want.
Smart. You also mentioned visual hierarchy earlier for environment design. Primary, secondary, tertiary shapes.
Right. That's a core design principle. It's about guiding the viewer's eye. Your primary shapes are usually the big architectural forms.
The main structures.
Yeah. Secondary shapes are things like statues, gravestones, railings, medium-sized details that add interest. And tertiary shapes are the small stuff, debris, weeds, little props that add that final layer of realism and ground the scene.
So different levels of detail and importance.
Exactly. And you use your real-world references to inform how much detail to put where, creating a balanced composition, leading the eye, supporting the story.
Okay, building our worlds piece by piece, texture by texture. Let's look behind the curtain now at the actual production workflows, maybe in that VAD context.
Yeah, in virtual production, especially with a team, solid best practices are absolutely key for an efficient pipeline. And rule number 1 is consistent naming conventions.
Naming things properly seems basic but important.
Crucial. Using prefixes like SM for static meshes, non-animated models, or clear names for textures means everyone on the team instantly knows what an asset is and what it's for. Clarity is speed.
Makes sense. So what's the typical flow for getting a new asset like that metal lamp ready and into Unreal in a VAD pipeline?
Well, even before you import into Unreal, you need to prep it in your 3D software, like Maya. Set up materials correctly, maybe name an emissive channel if part of it glows. Give the asset the right name, like SM lamp. And critically, zero out its transforms, make sure its position, rotation, and scale are all at 0 or 1 respectively in Maya.
Reset its coordinates. Why?
So it imports cleanly into Unreal at the world origin without unexpected offsets. Then Inside Unreal, it's good practice to have a sandbox folder in your content browser.
A testing area.
Exactly. Add and test new stuff there before moving it into the main project structure. When you import, you'll see options like combine meshes.
Right, you mentioned that. Combine or keep separate.
Depends. If the lamp is one solid piece, combine is fine. If it has parts you want to move separately in Unreal, you'd uncheck that.
Got it. And the textures for the lamp.
Often, if your textures are named well, like SM Lamp Albedo, SM Lamp Normal, Unreal might find and link them automatically during import, or you just drag them into the content browser. Unreal's pretty good at setting default compression settings, too, to help with performance.
And then we use those master materials again.
Absolutely. Master materials are central to the VAD pipeline. You'd have your standard MBasic material, you'd create the instance My Metal Lamp Top, assign the instance to the lamp mesh, open the instance, plug in the lamp's specific textures. Done. Consistent, efficient.
Okay, assets are prepped, imported, materials applied. How do we structure the actual virtual world in Unreal for a big project?
That's where levels or maps are key. You usually have a main persistent level. Think of it as the master container.
Okay.
Then inside that, you use sublevels to organize everything. In the Slay project example, they had separate sublevels for the temple, the characters, the lighting, the terrain.
Breaking it down into logical chunks.
Exactly. This lets you control visibility, easily turn sections on or off. And crucially, it allows multiple people to work on different parts of the world at the same time without conflicts. One person does lighting, another works on the temple layout.
Ah, parallel workflows. Very efficient for teams. How do these sublevels work with Sequencer for cinematics?
That's where level streaming comes in. It's
Okay.
really powerful. You can load and unload these sublevels dynamically during your sequence.
So only load what the camera sees for a specific shot.
Pretty much. In Sequencer, you add level visibility tracks. You put little markers. Green means load this sublevel. Red means unload it at different points on your timeline.
Great for performance, I bet.
Huge for performance. You only have the necessary bits loaded for each shot. To set it up, you create empty levels, add them as sublevels to your persistent level, then control them with those visibility tracks in Sequencer.
Dynamic world management within the cinematic. Cool. How do teams keep all this stuff, assets, levels, changes, synchronized?
Source control. Absolutely essential for teams. Systems like Perforce or Git.
Like version control for code, but for game assets.
Exactly. Everyone syncs their work to a central server. It prevents people from overwriting each other's work, tracks changes, lets you roll back if needed. Indispensable for collaboration.
Okay, organization, workflows, levels.
Now, Will.
We've got the big picture. Let's zoom back in on creating the actual assets themselves, that real-time asset creation pipeline.
Right. So a pretty standard workflow involves several steps, often using different software.
What's the typical path?
Often starts with blocking out the basic form in Maya, like we discussed for whiteboxing. Then you likely take that into ZBrush for high-resolution sculpting, adding all the fine details.
ZBrush for the fancy details.
Yeah, wrinkles, scales, wood grain, whatever. Then comes UV unwrapping, laying out that 2D map of your 3D model. Super important
So
step.
we get the UVs right.
Absolutely. After that, you create the low poly model. This is the optimized version that will actually run efficiently in Unreal Engine. It might be based on your blockout or derived from the high poly sculpt.
And finally,
You bake maps and texture it, usually in something like Substance Painter. Baking transfers the detail from the high poly sculpt onto the low poly model using normal maps and other textures. Then you bake the final colors, roughness, metalness, etc. in Substance Painter.
Maya, ZBrush, Substance Painter. Quite a tool set needed. Let's dig into that ZBrush sculpting part. How do you get really intricate details, like scales on a creature?
Well, one technique involves using the UVs to help guide the sculpting. You can actually straighten out the edges of your UV shells.
In the UV editor.
Yeah, this helps make the sculpted detail flow more predictably across the surface. You can even bring in reference images, like photos of actual turtle shell pieces, right into the UV editor to help you get the scale and pattern right.
Using reference directly in the UV layout, clever.
Yeah, and then you could create an alpha map, like a black and white stamp of a single scale, maybe in Photoshop or Substance Painter. Import that alpha into Substance Painter, apply it to a fill layer's color channel, and scale it down to get the repeating scale pattern you want.
So using a texture to create the base pattern.
Exactly. You could even export that tileable scale texture from Substance Painter and then use it as a brush alpha in ZBrush for more direct sculpting of the scales onto the high poly model.
Bouncing between tools, using textures from one to drive sculpting in another.
Okay, so we have this amazing high detail sculpt. How do we get all that detail onto the low poly game model?
That's the baking process, usually done in Substance Painter. You use the Bake Mesh Maps feature.
Okay.
You load your low poly model, and you also load a version of your high poly sculpt, often a decimated version, which means it has fewer polygons, but keeps the main shape.
Right.
Then Substance Painter compares the two and bakes the differences into texture maps for the low poly. The most important ones are the normal map, which fakes the fine surface detail. Makes it look bumpy and detailed even though it's low poly.
Exactly. And the ambient occlusion, AO map, which adds contact shadows and crevices. Once those maps are baked onto your low poly,
Then what?
then you can use Substance Painter's smart materials. These are pre-made materials that cleverly use that baked information, the normal map details, the AO shadows, to automatically generate really convincing textures on your optimized model.
So the bake maps tell the smart materials where to put wear and tear, dirt, etc.
Pretty much, yeah. It's a very powerful workflow for getting high-quality results efficiently.
Okay, sculpting, UVs, baking, a complex but powerful asset pipeline. Let's swing back to lighting again, but look at a specific example. How was it done in that sleigh project you mentioned?
Right, the Slate Project lighting provides a good practical example. They started, as is often recommended, with all lights off. Build it from black.
Start fresh. What were the essential lights they added first?
The core setup included a directional light for the sun, a skylight for overall ambient light, exponential height fog for atmosphere, volumetric clouds for the sky, and a sky atmosphere component for a physically based sky simulation.
The usual suspects for environment lighting.
Pretty much the standard toolkit. Good practice is to zero out their transforms. When you add them, rename them clearly in the World Outliner.
Keep it organized.
Always. For the directional light, the sun, set it to movable and enable atmosphere sunlight. Sky atmosphere defaults are often a good starting point. And for the skylight, enable real-time capture, so it picks up light from the sky atmosphere and clouds dynamically.
Okay, standard setup. You mentioned something called sunspill being used. What's that technique?
Yeah, sunspill is a nice touch. It creates that softer glow that seems to wrap around edges where the main sunlight hits. Makes it feel less harsh.
How do you achieve that?
Usually, you duplicate your main directional light. Then you rotate this second spill light just slightly differently from the main sun.
Okay, a second sun, slightly offset.
Yeah. Then you tweak its settings, maybe lower intensity, make the color a bit warmer, and definitely increase its source angle and soft source angle quite a bit. This makes it a very soft, broad light source.
So it just adds a soft wash around the main light?
Exactly. You might also lower its specular scale so it doesn't add strong highlights. And remember, the source angle on your main sun also controls how soft its shadows are.
Right, balancing the main sun's softness with the spill light. What about filling in the shadows, making them less black?
In the Slate project, they used a third directional light called shade fill. But it was mentioned this was more of a working tool during the lighting process.
To help see into the shadows while working?
Yeah, maybe not something that stayed in the final render, just a way to temporarily lift the shadows and see detail while iterating. Unreal also has a detail lighting view mode.
What does that show?
It just shows the normal maps, basically the surface bumpiness without color. It's really useful for judging the quality of your shadows and how light is falling across surfaces.
A technical view for checking lighting quality.
Yeah. The general artistic approach seems to be start with the essential lights for the overall mood, then get more specific, refining intensities, colors, directions, adding smaller lights like rect lights for specific areas, really stylizing it.
Start broad, then refine. Makes sense. Okay, we've covered a lot on assets and lighting. Let's loop back one more time to Sequencer and explore some more detailed features for actually making the cinematic shots.
Sure. So Sequencer, as we said, is that multi-track editor. You can find existing sequences in your project, often in a sequences folder.
Right.
But again, for experimenting without messing up your main project, it's really smart to create a dedicated test level and maybe a test sequences folder. Keep your experiments separate.
A sandbox for Sequencer, what can we do in there?
Well, create a simple level plane, directional light maybe at intensity 1.5. Then make a new level sequence in your test folder. Use a consistent naming convention for shots like test sequences 0002, test sequence 020, etc.
Okay, got our test sequence.
You can drag existing assets, like character animations, from the content browser onto the timeline. But what's really cool is using spawnable assets.
Spawnable, like they appear just for the sequence.
Exactly. You can add things like a point light directly into Sequencer. It only exists while that sequence is playing.
Oh, wow. So you could have a light follow a character just for one shot.
Precisely. You keyframe its transform location, rotation, scale right in Sequencer using the Add Key button or just hitting Enter. You can animate its movement, even its color, over the course of the shot.
Very dynamic. What about switching camera angles within one sequence?
That's done with camera cuts. You add a camera cuts track, then you can tell it which camera actor in your scene to use at different points in time. Creates clean cuts between shots.
Seamlessly switch views.
Yep. And you can adjust focus for each camera right in Sequencer too. Use the little eyedropper tool in the camera's focus settings to pick exactly what you want to be sharp.
Fine-tuning focus per shot. Okay, sequence is built, cameras are cutting, lights are spawning, time to render again.
Right. And for high-quality output, the movie render queue is the way to go now. It replaced the older movie scene capture system.
Movie render queue. Got it.
You add your sequence or specific shots from it to the queue. Then you configure the render settings there, often presets you could load or create for things like final quality or draft quality.
More control than the basic render button.
Oh yeah, much more. Better anti-aliasing options, motion blur settings, output formats. It's the professional way to render cinematics from Unreal. You set it up, hit render, and it processes everything in the queue.
Okay. Looking at those complex sequences from the Slay project, what else were they doing?
Well, you'd see lots of tracks. Camera tracks, obviously. But also tracks controlling lighting effects, maybe toning character visibility on and off for specific moments.
Hiding or showing characters mid-shot?
Yeah, if needed. You can easily duplicate tracks, like a camera track, and then just change which camera it's bound to using the camera binding ID in the properties.
Yeah.
Makes iterating on shots easier.
Break variations.
Exactly. And a big thing was organizing sequences into modules, similar to how levels are split up. Keeps things manageable.
Modular sequences. And you mentioned changing material properties in Sequencer. How does that work?
Yeah, that's super powerful. You use material parameter collection tracks.
Okay.
These let you animate specific parameters you've set up in your materials, like maybe the brightness of the base color or in the emissive intensity just for that specific shot in Sequencer.
Without changing the actual material asset.
Exactly. It's a temporary override just for the cinematic. So you can make a material glow brighter for a dramatic moment in one shot without affecting it everywhere else. Really useful for shot-specific tweaks.
Sequencer really is the conductor of the whole orchestra. Okay, as we wrap up, let's bring in some wisdom from that book, Unreal Engine for Filmmakers. What are the key takeaways?
Well, the book really highlights how Unreal's sequencer and camera system kind of just work for getting high-end visuals, even for small teams. It's incredibly enabling.
But there's a learning curve, right? Especially if you're new to game engines.
Oh, for sure. It acknowledges that. The advice is start small, do a simple 10-second fly-through, practice the whole process end to end.
Build confidence on simple projects first.
Exactly. And it stresses having foundational knowledge in 3D basics, modeling, UVs, texturing, maybe rigging and animation, or knowing how to use Unreal's control rig for animating directly in the engine.
The fundamentals still matter.
Absolutely. Understanding real-world lighting helps immensely when using Unreal's lights, directional, skylight, lumen, post-process volumes.
And having a vision.
Yes, have a clear artistic vision and emotion you want to convey before you just start adding cool effects. Think about cinematography, composition, use the cinematic camera controls thoughtfully.
Don't just play with the toys.
Right. Use post-processing for atmosphere fog, lighting effects, and for final color grading. Nanite is amazing for detail, but don't just fill your scene with junk because you can. Believable animation and physics are key.
What about sound?
Crucial. Sound design and music are half the experience, the book reminds us. And you can sync audio tracks right within Sequencer.
And for learning more.
It points to the official Unreal Docs, Epic's online learning portal, the Unreal YouTube channel, plus places like CGMA and Nauman Workshop. Reliable resources are key.
Good recommendations. What about the filmmaking process itself within Unreal?
It emphasizes traditional pre-production. Shot lists, storyboards, you can even do rough animatics in Unreal, asset lists with references, optimize your project using LODs, Nanite wisely, instancing the foliage tool.
Standard production discipline.
Yeah, it covers character workflows, camera animation in Sequencer, transforms focal length, aperture, shape, cuts, creating VFX with Niagara, particles for fire, smoke, rain, physics, even in-camera VFX.
Niagara for effects.
Right. Adjusting post-processing, especially color grading after lighting is set. Then the rendering via movie render queue, choosing image sequence versus video, resolution, frame rate, anti-aliasing, motion blur, high-quality bloom.
The whole pipeline.
Pretty much.
Yeah.
It even touches on editing and sound post in external software like Resolve or Premiere, and mentions simpler tools like Previs Pro or City Tracer as alternatives for some tasks.
And licensing.
Big final point. Always respect the licensing for marketplace and Quixel assets. Use them correctly. The main message is, start small, build confidence, use the amazing learning resources, and embrace real-time filmmaking.
Wow, okay. We have absolutely covered a ton of ground here. From sequencer basics, lighting techniques, building assets and environments, VAD workflows, all the way to the core principles of making films in Unreal.
It's a deep topic.
Yeah.
But what's really exciting is how much power Unreal puts in the hands of, solo creators or small teams. The ability to get results that used to need huge studios is, well, it's transformative.
It really does make you think, doesn't it? How could the immediacy of real time, that instant feedback, actually change your creative process as a filmmaker? What kind of stories could you tell? What could you explore when you can iterate that quickly?
It's a massive shift in potential, yeah. And look, if you're listening and feeling inspired to go deeper, definitely check out the official Unreal documentation. Epic's online learning portal is fantastic, and the Unreal YouTube channel has endless tutorials.
So many resources out there.
Absolutely. A whole world of knowledge.
And maybe the best next step is just try something small, a little experiment.
Totally. Try making just a super short sequence, like 10, 15 seconds. Focus on one thing we talked about, maybe simple camera animation and sequencer, or setting up a basic 3-point light setup.
Get your hands dirty.
Exactly. That hands-on experience is the best way to make it stick and spark more ideas. Thanks for joining us for this deep dive.
Now it's your turn. Please be careful down there. Especially you, 17.